Hey everyone, welcome back for another deep dive to help get you ready for the coming week in classical conversations. This time we're tackling week 12 of the Math Map curriculum. Let's be real, some of this stuff can feel a little intimidating to teach.
It can be.
But don't worry, we are here to break it down. This week, it's all about polygons. So let's start with the basics.
So a polygon, the source material defines it as a closed two-dimensional shape with straight sides. So think of it like drawing a figure without lifting your pencil and making sure your lines are straight. No curves allowed.
So a circle wouldn't be a polygon.
Circles are out, but squares, triangles, octagons, those are all polygons.
Gotcha.
And they're everywhere in our world. Look around you, building signs, even the tiles on your floor.
That's true.
Polygons are the building blocks of so much of what we see.
I bet if we start looking, we'll see them everywhere. And our source even mentions polygons in the Bible.
It's true. In Exodus, God gives very specific instructions for building an altar using polygon shapes.
Wow.
It really highlights how math and geometry specifically is woven into all of creation.
Okay, so we've established that polygons are important. There are so many types.
There are.
Let's break them down, starting with triangles. Why don't we start there?
Triangles are the simplest polygon, just 3 sides and 3 angles, but there's a surprising amount of variety within that basic structure.
Each of these types has specific properties that are important to understand. For example, if we know a triangle is a right triangle, we can use the Pythagorean theorem to figure out the length of its sides.
The Pythagorean theorem, that famous leg squared plus leg squared equals hypotenuse squared formula, only works for right triangles.
It's a powerful tool, and it shows how understanding this specific type of triangle you're working with unlocks important mathematical possibilities.
For sure.
Speaking of possibilities, the source also dives into something called special segments, altitudes, medians, perpendicular bisectors.
Yeah.
Can you help us understand what those are?
So think of these as lines we can draw within a triangle that give us more information about its structure. An altitude, for example, is a line drawn from one corner of the triangle perpendicular to the opposite side, like measuring the height of the triangle.
Okay, that makes sense. And I loved that this source used the example of a snowflake to illustrate how these shapes appear in nature. It's such a beautiful reminder of God's handiwork, even at a microscopic level.
Snowflakes are a perfect example of the intricate geometry found throughout creation.
Moving on from triangles, let's talk about another big category of polygons. Quadrilaterals.
Okay.
I have to admit, I was a little overwhelmed by all the different types at first.
Understandable.
Squares, rectangles, parallelograms, rhombuses, trapezoids, kites.
It's a lot.
It's a lot to take in.
It is.
But our source provides a really helpful visual aid, a Venn diagram that shows how all these types relate to each other.
It does.
That Venn diagram is a lifesaver. Can you walk us through it?
Sure.
What are the key things we need to know about each type of quadrilaterals?
Well, let's start with parallelograms because they're the foundation for understanding many other quadrilaterals.
What makes a parallelogram special?
A parallelogram has 2 key properties. Its opposite sides are parallel, meaning they'll never intersect. And they're congruent, which means they're the same length.
So it's like a slanted rectangle.
You got it. And because of those parallel sides, the opposite angles in a parallelogram are also congruent.
Okay, so rectangles.
A rectangle is basically a special type of parallelogram where all 4 angles are right angles. So it takes the properties of a parallelogram and adds that perfect 90-degree angle to each corner.
Okay, and a square is just a rectangle with all sides equal.
A square is like the VIP of quadrilaterals. It's both a rectangle and a rhombus.
Wait, a rhombus. What's that?
A rhombus is another type of parallelogram, but its defining feature is that all 4 sides are equal in length. It can be slanted like a parallelogram, but all its sides must be the same length.
Ah, I see. So a square is like the perfect combination of a rectangle and a rhombus.
Yes.
Then we have trapezoids and kites. Those seem a bit like the odd ones out.
They are unique, but equally important to understand. A trapezoid has only 1 pair of parallel sides, unlike the parallelograms too. And kites, they have 2 pairs of adjacent sides that are congruent,
Okay.
giving them that distinctive kite shape.
Okay, so we've got all these different types of quadrilaterals, each with its own unique properties.
Yes.
But why does all of this matter?
Well,
What does this mean for us as we teach our kids?
it means understanding these properties is crucial for figuring out things like area and perimeter, which are essential in so many real-world applications.
All right, let's get practical. The source mentions a 4-day lesson plan.
Yeah.
What are some of the key activities we can use to bring these concepts to life for our kids?
The 4-day lesson plan is full of great hands-on ideas.
Oh, good.
For quadrilaterals, there's this fun activity called living quadrilaterals, where the kids actually use their bodies and some string to form the shapes. They become the vertices themselves. And it really helps them visualize the properties we've been talking about, like which sides are parallel, which angles are congruent.
Speaking of visualizing, the tile it up activity for area is super clever too.
It is.
I like that one.
It's a great way to make the abstract concept of area more concrete. They literally get to cover shapes with tiles or unit squares and see how many it takes to fill the space.
I bet the shape within shapes activity is a good one for when they're starting to work with more complex figures.
It helps them break down those complicated shapes into the basic polygons we've been discussing.
Yeah.
So they can see, for example, that a house shape might be made up of a rectangle and a triangle.
And then they can use the formulas they've learned to find the area of each part and add them together.
It's all about building those foundational skills.
So if we're thinking about applying this knowledge at home, what are some practical tips for parents? Like, how do we make this stuff engaging for our kids?
The key is to connect it to their world. Find examples of polygons in your home, in nature, in art.
Like pointing out the hexagonal tiles on the bathroom floor or the triangular shape of a slice of pizza.
And don't underestimate the power of hands-on activities. Let them build with blocks, design structures with straws and connectors, create patterns.
I'm sensing a theme here. Hands-on learning for the win.
It's so much more effective than just memorizing formulas.
The source also mentions a Polygon detective homework assignment and an area design challenge.
The detective assignment gets kids looking for different types of quadrilaterals around their house, which helps them apply what they've learned in a real-world setting.
And the design challenge lets them get creative with area and perimeter. Maybe they could design a dream bedroom or a backyard playground.
And what's important is that they're using their math skills in a way that's meaningful to them.
And potentially avoiding a meltdown when we actually open the math map book for week 12.
Fingers crossed. But even if there are a few bumps along the way, remember, we're all in this together.
That's the beauty of the CC community, right?
Yes.
We can lean on each other for support and encouragement.
We've covered a lot of ground.
We have.
From the basic definition of a polygon to its various types, properties, and real-world applications.
But before we wrap up, I have one final thought-provoking question for our listeners. Based on the source material, the source mentions that understanding polygons helps us appreciate the beauty of God's creation. How can we, as CC parents, encourage our kids to see those connections between math and the world around them? How can we help them move beyond just memorizing formulas and truly grasp the wonder of these shapes that are literally woven into the fabric of creation?
That's a fantastic question. It really gets to the heart of why we teach our kids anything, especially in a homeschool setting like Classical Conversations. We want them to see the interconnectedness of knowledge, to appreciate the beauty and order in God's world.
It's not just about getting the right answer on a test, right?
It's about cultivating a sense of awe and wonder, recognizing that math isn't just some abstract set of rules. It's a language that describes the very structure of the universe.
Wow.
And polygons, with their precise angles and relationships, offer a perfect opportunity for that.
So as CC parents, how do we spark that sense of wonder? How do we help our kids make those connections?
I think it starts with us. Our own enthusiasm is contagious. If we approach math with a sense of curiosity and delight, our kids are more likely to do the same.
So instead of groaning when we see those polygon problems in week 12, we should be like, ooh, let's discover something amazing together.
And remember, CC is all about bringing learning to life. Don't be afraid to get creative.
The source even mentioned the symbolism of polygons in religious architecture. That could be a fascinating rabbit hole to explore with our kids, especially as we study cathedrals and churches.
There's so much to discover when we start looking at math through the lens of history, culture, and faith. It enriches our understanding of both the math and the subject it's connected to.
So as you work through those problems with your kids, take a moment to step back and marvel at the wonder of it all.
See you next time.
Wow.